Okay, welcome back. Here is the big moment. This is probably the most important factoring lesson you're going to get from me, and probably the one that will have the most impact on your understanding and advancing your knowledge in quadratics. So, we're going to factor monic trinomials. So what is a monic trinomial? I'm referring to the quadratic trinomial x squared plus bx plus c. So the word monic here just means that we have a 1 in the front. These are considered the easier of the two types of trinomials that we're going to factor over the next two lessons. So in the next lesson, we'll deal with the situation where you don't have a 1 in the front. Alright, so just to get back on track, this expression here is in factored form, and if you apply FOIL and you expand it, what do you get? Well, you get x squared plus 4x, and if you multiply the second pair, you get 2x and 8. And what you have here, when you expand it, is exactly the starting point for the factoring question. So if I asked you to factor this expression here, the answer would simply be x plus 2, x plus 4. The challenge is, though, what if you didn't have this? What if you didn't have that expanded process available? Well, how do you go back and figure this out? It turns out that the grouping topic that we covered in the previous lesson will get us there. So you actually already know most of the process. The tricky part comes with the arithmetic. Here's your first question. What I'd like you to do is think about the following. I'd like you to think about two numbers that would multiply to 20 and add to 9. Notice that I circle these operations here. The reason is sometimes you'll have negative numbers, and I like this template when I do factoring. So, take a moment and figure out those numbers. You're welcome to pause the video. Okay, so the numbers are 4 and 5. This method that I'm showing you is one of several methods that can be used for factoring. The reason I prefer this specific method is because it helps you with the general case when you do not have a 1 in the front and it is non-monic. What you can do here is split the middle term in the proportion of 4x and 5x. What I mean is, I use the two numbers over here to split the ratio of 9x into 4x and 5x. You could also write 5x and 4x. If you were to pause and go back to the previous video on grouping, you have exactly what I showed you in the last two examples. You have a grouping question, see? So without any delay, let's take this here and factor the first pair of terms. And let's factor the second pair of terms. Notice that the second pair has a 5 in common. And when you divide 20 by 5, you get 4. Again, the same binomial appears twice. This means that your grouping is correct. And you can take out that x plus 4, leaving you with your final answer in factored form, x plus 4 times x plus 5. This method has a name, and again, it is one of several methods. This method is called, most often, decomposition. I am not going to explore other methods, and there are many nice videos on YouTube where you can explore other methods. I just want to get across the general idea of a method that can work for everything when it comes to trinomials. So, why is it called decomposition? The key reason is that you're taking the 9x here and you are literally decomposing it into two terms. So that's your first example. I took a while explaining it and hopefully you got the most out of it. But there are things that you're going to notice as we go through this video and there are shortcuts that you can take. For example, the numbers that you chose here, 4 and 5, are exactly the numbers that appear in the answer, 4 and 5. So you could actually jump right to the end of the question. I am going to go through the whole process because that process helps you in future and more difficult questions. Here we go. So I'm probably going to cover a lot of questions for you. It's really important that repetition is employed here so that you can get the most out of the experience. So the more of these you do, the better. In this case, we want two numbers that multiply to the number at the end, which is -10, and we add to the number in the middle here, the coefficient, which is 3. These questions that have negative signs in your search tend to be a little bit slower, but you can find a way to do these. Just be patient with your arithmetic. So I think that most often what people will do here is say, well, give me two numbers that multiply to 10. And don't worry about the minus sign for a second. There are only two possibilities, 1 times 10 and 2 times 5. The key thing here that I want you to understand is that when the product is negative, really, you're looking for a difference of some sort. And the difference is 3. It could be positive or -3 if it was a different question, but for here it's +3. So in your search here, look for numbers that differ by 3. And there they are, 2 and 5. So what you can do now is just write down 2 and 5. Because the product is negative, one of these numbers has to be negative and one has to be positive. So the number that's negative is the 2. And the reason is because the sum here has to be +3. So the bigger of the two numbers, the larger of the two numbers, must be 5. Let's split this trinomial into 4 terms. So I'll write down the 5x here, and then I'll write the -2x here. Notice that I'm splitting the middle term based on this proportion, so you see the -2 and the 5. It doesn't matter which way you write it. I just chose it this way for this particular example, but I'll experiment with you through this video. We can group these terms as follows. The first pair of terms have an x in common, and that leaves you with x plus 5. And the second term, second pair of terms has a -2 in common, again leaving you with x plus 5. So there you have it. You can take out the x plus 5, and if you imagine again that the x plus 5s were invisible, the x minus 2 would be left over, and that would be the result. Notice that these two numbers that you have searched for and found are exactly the two numbers that appear in the answer. Let's do one more. Okay, so really the questions can escalate in terms of the size of the numbers that you're going to look for, but also the positive and negative signs are what throw people off. In this case, the product is positive and the sum is negative. The only way that you can have a product that's positive and a sum that's negative is if both numbers that you look for are negative. This question is extremely similar to if this 8 was positive. If you did this question, you would quickly say 3 and 5. So you can use that logic here as well. I'll write down the factors of 15, which are as such. And the two numbers that I'm looking for in key are the 3 and the 5. Because the product is positive, because this product is positive, it means we need a sum. So we need the two numbers here to add up to 8. At least in magnitude to 8. Usually when I talk about sum here, I kind of ignore the sign of this number here because I can fix that at the end. So let's apply the decomposition method, and if you feel that you're getting the hang of the pattern from the previous two examples, you're more than welcome to just jump to the answer. So there we go. We can decompose each of these pairs of terms separately. X is common to the first pair, and negative 5 is common to the second pair. Notice that we have an x minus 3 that is common to both terms. We take out that x minus 3, and if you like, imagine that that minus 3, or the x minus 3, is invisible for a second. You would be left with x minus 5. Okay. My notes indicate that I have another 10 of these left in total, so just have some Gatorade or something, because you're going to be here for a little while. But I promise you, when you do enough of these questions, it really builds up your confidence, and you can really do well in terms of factoring. I can't emphasize enough how much factoring is important in math. So in this question, we want a product that's negative and a sum that's positive. So immediately, I'll put a template there of a plus and a minus. Also, because the product is negative, I really am looking for a difference of 2. So I need two numbers that are 2 apart, that multiply to 35. So allow me to experiment here. I could do 1 times 35, and I can keep on going, and the next one would be 5 times 7. And that's it. 5 times 7 is 35. And those are the two numbers that would fit into this template. But could I search it a different way? Yeah, you could. What if you don't know your times tables too well, and also you might have a calculator handy anyway? Try this out. I'll do it in orange so that you can differentiate. And give me two numbers that differ by 2. So I'll just pick two numbers here, like 4 times 6. What's 4 times 6? Okay, 24. Is 24 below or above 35? Well, it's a little too low. So let's just increase those guys by 1. Oh, there it is. See, I didn't even know my times tables here, and I still could get the answer by just guessing and checking. In fact, when the numbers are really large, but you are informed that it can be factored, I tend to do the thing in orange here because it's quicker when there's too many combinations of numbers to look for, or the numbers are too large for me to think about in my head. So in this case, the numbers are 5 and 7. 5 and 7. So who's bigger? 7 is bigger, so we got to make 7 positive and 5 negative, since the sum is going to be 2. Positive 2. Let's decompose this trinomial using the numbers 7 and negative 5 as coefficients on the x. There you go. And we'll do the decomposition step. So we can take x from the first pair and negative 5 from the second pair. We see the same binomial appear twice. That's a good sign that we've done this decomposition approach correctly. There's x plus 7, and there's x minus 5. Notice that the two numbers that we had here are precisely the two numbers that appear in the factored form. So if you want to jump to the answer, be my guest. But for the remaining questions, I will do it the long way. Here we go. Okay, positive numbers. Usually, in my experience working with people, I found that when the numbers are positive, the search process is very quick. So, two numbers that multiply to 18 and add to 11 are, well, in this case, I'm not going to explore too much on the side here. I think people usually know their 9 times tables well, so 9 times 2 is 18. Let's decompose this trinomial. I'll put the 9 first as a coefficient, and then the 2 second. I'd like you to try this question on your own by putting the 2x first and the 9x second, and you'll see that it's the same thing anyway. It results in the same answer. If we decompose and then follow it by grouping here, we can take out an x from the first pair and a 2 from the second pair, leaving us with the same x plus 9 binomial. So there you have it. Alright, here's a minus sign. two numbers that multiply and add to negative 63 and positive 2. So I'm sure that you can search for the numbers, although 63 has lots of factors. So let me do the thing I did in orange earlier. This time I know my times tables, and I'm sure you do too, but let's experiment. Just think of two numbers, and notice the minus sign here. Think of two numbers that differ by 2. I'm just going to pick 5 times 7. What's 5 times 7? 35. Is that too low? Yeah, it's too low. We need 63. How about 6 times 8? I shouldn't even check this one because I need a product that's odd, but hey, no harm, no foul. Okay, how about 7 times 9? There it is. This is a bit more aggressive, this approach, but if you have very quick arithmetic and the numbers are too large to know your factors for, you can still figure it out this way quite fast. So the numbers are 7 and 9. However, one of these numbers must be negative. So it looks like the 7 is negative because the 9 must be positive since it's the greater of the two numbers and the sum here is positive 2. Let's take this trinomial and decompose it as follows. You know what? I'm going to put the minus 7 first, and then I'll put the positive 9 as the coefficient after. There you go. You can take out the x from the first pair, and you can take out a 9 from the second pair because 63 is divisible by 9, leaving you with x minus 7, x plus 9. Hopefully by this point you're getting into some type of a rhythm and these questions will go by quicker and quicker. I think we have a few more to go, and hopefully I can get this done in one take because factoring is very, very laborious. Alright, here we go. Ooh, big numbers. So don't let this intimidate you. They are positive, so at least you're not going to be worrying about differences. I'm going to try something a little bit different with you here. I'm sure that many of you recognize the answer immediately as 10 and 11 because when you have a number that ends in a 0, it has to be divisible by 2, 5, or 10 at least. So those are quick things to look for. So I see a 10 right away, and 10 times 11 is 110, and 10 plus 11 is 21. I'll experiment with you on the side here, just more for your insight and entertainment. I want you to think of, because the product is positive, I want you to think of two numbers that add to 21. So how about this? How about 5 and 16? They add to 21, don't they? So what's 5 times 16? 80. 80 is too low. So if you bring these numbers closer together, then the product goes up. So let's try 6 and 15. See, I'm bringing them closer together, but you still get a number that is going to be a little bit larger. Actually, 10 larger. Okay, let's try 7 and 14. Ooh, that's getting there. So that would be 98. And then 8 times 13. Okay, this is ridiculous now. I think you know your times tables. But what I'm trying to show you here is that you could jump very quickly and search for that answer, which is getting close to where we want to be. And I think that we're almost there. And there it is. So that's 108. So I guess the big thing here that I want you to see is that the product can be found by looking for a sum instead. Anyway, let's go back here and decompose and factor. So I'll put the 10x and the 11x and the 110. So if we take an x out from the first pair, that's x plus 10. And if we take an 11 from the second pair, that's x plus 10 left over also. So we can clearly see that it's x plus 10 and x plus 11. Okay. Here's a simple one. Small numbers. The emphasis should be that you want to not mess up the signs. So two numbers that multiply to 2, well, you only have one choice here. So 2 and 1. But because the product is positive and the sum is negative, they have to both be negative. And that's it. So we can decompose the 3x, the negative 3x in the middle term, into negative 2x and negative 1x. I'm not going to write the 1 down though. And then we group it. Take an x out from the first pair. And from here you can't take out much, but you need whatever is going to factor the remaining part. You need to have x minus 2. So I need to take out a negative 1. And that will reverse the signs of the subsequent two terms. So that allows us to match, because if those don't match, then you can't factor this, or your factoring is not complete. Okay, one more question. You made it, and so did I. Okay, two numbers that multiply to negative 36 and add to 5. So I don't think this one's too challenging, hopefully. If the 9 times tables are in your wheelhouse, we got it here. A positive 9 and a negative 4. If you weren't sure, you could do your times tables here. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. You see how it wraps on itself? I go up, and then I go up again. That's how you know you've looked at all of them. The last thing you want to do is write down factors and just kind of scramble them around and kind of aimlessly write things down. So in this case, we need a difference because that product is negative. We're looking for a difference of 5. And there's the numbers that differ by 5. So back here, let's decompose and group. So we have the following 4 terms. Let's do the grouping step. From the first pair we can take an x, that leaves us with x plus 9. And from the second pair we can take a negative 4. Notice that negative 36 divided by negative 4 is positive 9. That's important so that they match. The good news is that even if you mess up a sign, this process is unforgiving. If they don't match, you screwed up and you got to go back and figure it out. So now it's time for you to take a break, because that was a lot of work. But come back and I'll hit you with another dozen questions or so on non-monic trinomials where we have a coefficient that is not a 1 in the front. Okay, thank you so much.